Hello friends, in this video we're going to be looking at product rule, and for product rule now, the basic doctrine for solving product rule is due to the fact that it's possible for you to be given expressions in this form. You have 2x squared plus 3 2x squared plus 3 into x raised to power 4 minus 5. So notice now that in this case now we have two functions multiplying themselves, right? And this, you would otherwise be able to solve this by opening the bracket, but there are some functions you'll be given that you will not be able to open the bracket. So when you have two functions multiplying themselves, in this case you have to use what you call product rule. And it's intuitive, right? Because product would mean multiplication. So when you have this is what you do. So now for this, now the formula for solving product rule is given as dy over dx, which will be equal to u dv over dx plus v du over dx. Now let me explain what this formula would mean, right? You already know from our previous video that dy over dx is what you're going to have for your differentiation, right? So in order for us to solve this question now, you need to realize that this would be u, and your second bracket would be v, right? That's what we have in this case. So let's solve with that now. So we have our u, which is equal to 2x squared plus 3, right? 2x squared plus 3. So let's differentiate this now, right? Usually when we are given a function in y, right, if we want to differentiate that, it's going to be dy over dx. Since our function here is in u, therefore to differentiate this now, we're going to have du over dx, which will be equal to, now let's differentiate this following the method we've studied before. If we differentiate 2x squared, we're going to have 2 times 2 gives me 4. We subtract 1 from the power, which is 4x, right? And if we differentiate a constant now, that would give us 0. So no need to write that when we differentiate 3, that gives us 0. Let's move on. Now our v is equals to x raised to power 4 minus 5. X raised to power 4 minus 5. Let's move our screen. So we're going to have that in this case, what's going to happen there, we are going to differentiate and we have dv over dx. This will be equals to, if we differentiate this, 4 times the imaginary coefficient of 1 there would be 4. So we have 4x, we subtract 1 from the power, that will be 3, right? Beautiful. If we differentiate this negative 5, it gives us 0. Now let's finish this up and let's see how it goes. The formula says dy over dx equals to u dv over dx plus v du over dx. So in solving this question now, we're going to rewrite our u. We're going to follow the formula now. So rewriting our u, let's divide the screen so that we can solve here. That's not a straight line, but we'll move forward. So dy over dx now would give us, the first part of the formula says u, so we are going to rewrite our u, which is 2x raised to power 2 plus 3. 2 raised to power 2 plus 3. They say we should multiply that by the what we got when we differentiated v. So that's dv over dx. So what do we have as our dv over dx? 4x cubed plus v. Our value of v is x raised to power 4 minus 5. You will multiply that by what you got when you differentiated u, which is du over dx. So du over dx would give us, let me write it down here, 4x. That was what we had when we differentiated du over dx. Beautiful. Now let's open this bracket and get our final answer now. So 4x cubed, now multiply this 2x squared we have here, that will give us 8 x raised to the power 2 times x to the power 3 will give me x raised to the power 5. Now 4x cubed times 3 would give me 12x cubed plus 4x multiplied by x raised to the power 4, sorry. Now 4x multiplied by x raised to the power 4 would give me 4x raised to the power 5. Now minus 5 times 4x gives us minus 20x. So let's collect like terms. We're going to add this 8x raised to the power 5 to this 4x raised to the power 5, and this gives us 12x raised to the power 5. We just add the coefficients, right? So plus 12x raised to the power 3 minus 20x. This would be your final answer. We cannot add up anything there again. Now the next question. Now in this question, now you are told to evaluate this function y equal to 3x squared sine x, right? So as you have it now, 3x squared will be your u, sine x would be your v. The formula says dy over dx is equal to u dv over dx plus v du over dx. So what happens in this case now, we have our u, which is 3x squared. Therefore du over dx now will give us 2 times 3 gives us 6x. Our v is equals to sine x, right? So we have looked at how we can differentiate trigonometrical functions. So and if you differentiate sine x, you are always going to have that, in this case now, the v over dx. If you differentiate sine x, you're going to always have cos x. This is a standard, right? It's a standard differential, so you can look that up in our previous videos or your textbook. Now, so whenever we differentiate sine x, we have cos x. In this case now, we're going to have since our formula says u dv over dx, right? So you write our u, which is 3x squared. Dv over dx now, we had cos x plus our v is sine x, and du over dx gave us 6x. Now this would be our final answer because we cannot evaluate this further. You can choose to put your 6x in front of sine x, whatever the case may be, but this would be your final answer. Let's look at another example. Here's a very interesting question now, and in this question now you have root x into x squared plus 3x. So this would be your u and this would be your v. So if you have any idea on how to solve this question at all, pause the video and solve it and leave your answer in the comment section. So our formula says dy over dx equals to u dv over dx plus v du over dx. Therefore our u is the root of x now, the root of x, and this would be in the form x raised to power 1 over 2. Remember, for indices now, your roots can become a power of 1 over 2, right? So to solve this question now, we multiply this power by this coefficient here, which is imaginary, an imaginary 1, right? You know how to differentiate. So dy over dx would give us 1 over 2x, right? Now we subtract 1 from this 1 over 2 at the power. So if we subtract 1 from 1 over 2 at the power, that will give us minus 1 over 2. You just have to use your LCM, or you can use your calculator, you get that minus 1 over 2. So from indices now, we know that this negative sign will make this x go under our denominator here. So what we're going to have now would be 1 over 2 x raised to power 1 over 2 because of this negative sign. Now we can choose to finalize this now from our knowledge of indices by writing it in this form. Check our videos on indices if you do not understand what we are doing. So we have root x, right? The power of 1 over 2 becomes root. So now our v is x squared plus 3x, x squared plus 3x, right? If we differentiate that now, this gives us that our du, pardon me, dv over dx is equal to, if we differentiate this, we're going to have 2x, and if we differentiate 3x, we're going to have 3. Check out our video on differentiation, our first video on differentiation, if you don't understand how we are differentiating, right? Very true. So we have that. Now we can put down our final answer. Our formula says u dv over dx plus v du over dx. So we're going to have u, we rewrite our u, which is root x. So dy over dx will be equals to root x, right? So dv over dx, now we got 2x plus 3 into 2x plus 3 plus v. What was our v? We got our v to be x squared plus 3x. That's our v. So that's our v. The next part of the formula says du over dx. So what do we have as our du over dx? 1 over 2 root x. We cannot simplify this any further, so this would be our final answer. Thanks for watching. See you in the next video.